onward we go with the second half of the Algebra 2 multiple choice final preview for semester number 1. And we start right away with some silliness. 21. I go to break that down. I see a negative under the radical. What must I do? I out. Once I pull the I out, I notice the square root of 81. Now I could punch that in my calculator. Or remember, square root of 81 is 9. 9i. Not plus minus. It's not a quadratic. Be careful, be careful. I have a feeling that might be one of the choices. Okay, subtract. Write the answer in standard form. Subtract. Distribute your negative through. Constant term first. And we're good. Now, is that as important when we get there? Because it's going to be in the right order. When you're looking at it, you're just going to have to recognize that. Okay, multiply. Multiply, ladies and gentlemen, does not mean first times first, last times last, and I'm done. For some of you, again, this is why I'm a fan of doing the box, so you don't forget parts. But if you don't copy the problem down right, it really doesn't matter now, does it? So 10 minus 14i plus 35i minus 49i squared. Because again, when we're multiplying, we're filling in the box. We're adding exponents. We're multiplying coefficients. Once I get here, I remind myself, oh yeah, I squared equals negative 1. So in this case, negative 1 times negative 49 would be positive 49. And since we're putting it in standard form, it means I put the constant term first. 10 plus 49 is 59. 35 minus 14 is 21i, and I'm good. 24. Solve using the quadratic formula. Yes, it'll be right there, just like it is here. So I do the opposite of b, plus minus the square root of b squared minus 4ac all over 2a. Now here's our kicker. The answers, you'll notice, won't be in decimals. So when you get to this part, suggestion, type in what's under the radical, but don't put it under a radical. Notice I got my 3 squared minus 4 times 2 times negative 5. Okay. Because now I can play. And hey, the square root of 49 is a perfect square. That's cool. But you won't see any answers that look like that. Well, why not? Because I can simplify this. I can do negative 3 plus 7 over 4. I can do negative 3 minus 7 over 4. Notice I did parentheses, though. Otherwise, I can get some cuckoo answers. Negative 3 plus 7 is 4. Divided by 4 is 1. Negative 3 minus 7. Negative 3 minus 7 divided by 4. Oops. It would help, Harty, if you actually knew how to type it in the calculator correctly. Negative 2.5. Might I see the answer that way? Maybe. Am I prepared to have it as a fraction, though, too, if I need to? Absolutely. Again, folks, it's the details that are going to make or break you on this stuff, so just be cautious. All right, 25. Subtract. In other words, distribute the negative. I leave the first part alone. And that negative is just going to switch the signs on all of these. And I look for my biggest exponent values first. I'm just adding and subtracting coefficients at this point. Minus x to the fourth plus 3x to the third. Be careful, negative 7 minus 7 is not 0. Those do not cancel. If I owe somebody $7 and I borrow 7 more, now I owe them 14. And I don't have an x term anywhere, so it's just that minus 10. And I'm good. Bakery sells cupcakes. Oh, feeling hungry. The revenue from the sale is given by R of x equals 4.5x. In other words, we're selling the cupcakes for, $4.50 a piece. Hello. Suppose the function for the cost of baking x cupcakes is 1.25x plus 85. Write the profit function. Okay. Revenue minus cost. 4.50x minus parentheses. Okay, when in doubt, parenthesize, people. Because that minus goes to the 1.25x and the 85. If I forget that, that would mess up my profit function. And no, you won't see it written this way. It's going to be simplified. My profit function. Okay? But I got to remember the revenue minus cost part. Find the product, f of x times g of x. Don't freak out just because you're seeing x's in weird places. That just means take your f function, multiply it by your g function. Whether you use a box, whether you use FOIL, doesn't matter. You've just got to get this going. So, again, when we're multiplying to fill the box, we add exponents. And then we just multiply coefficients. We find our like terms. Again, we don't mess with the exponents anymore because now once the box is full, we're just combining like terms. And we're set. All right, so let's see, 28. Okay, remember when we graphed the inverses before? And what happened with their graphs? Their graphs reflect each other. Because remember, we had that dotted line that would go diagonally, sort of like this, and we said it was our fold line. That's what we'd look at with our inverses there, just that their graphs are going to reflect. Excuse me. Okay, now don't freak out on 29 when you get here, because you're going to look and you're going to be like, well, wait a minute, x to the fourth, that's not a square or a cube. What's he trying to do? We're going to treat this just like it's x squared minus 81. If it were x squared minus 81, we do x and x to get x squared. We do 9 and 9 to get 81, because again, remember, perfect squares, square root of 81 is 9, okay? And I do plus minus, but x times x is x squared. I don't want x squared, I want x to the fourth. So what same number plus plus is going to get me here? 2 is, but be careful, complete factorization. What's that mean? That means I've got to look and say, ooh, wait a minute. That's a difference of squares still, because x and 9. You're like, but so is that. Remember, when we're doing squares, there's only difference. There's not a sum. So you can't break down a plus squares, just a minus. So I take this last one. I look at it one more time. I go, okay, x times x is x squared. 3 times 3 is 9. Plus, minus. And that first one stays the same. Okay? Only differences break down with these. And that's it. 30. Factor completely. Again, you're going to have your cube sheet. Here's my perfect cubes. 216 is 6. So when we're doing this, again, write down what you cube to get each part. Because once you do, now it's just going to be following my difference of cubes, which says write the two terms down with the sign in the middle. Square my first term. Change the sign. So if I start with minus, I do plus. If I start with plus, I do minus next. Multiply the two terms together. Square the last term. And I'm done. Okay, and you're going to have this right there. You've just got to recognize and use it. Write an example of a cubic polynomial. Okay. Something that has the third power. A quartic. Think about this for a minute. What does that sound like? It sounds like quarter. And how much of a dollar is a quarter? Or how much of a game is a quarter? 1/4 or 4. Okay, that's all I need. Just being able to know that that's to the third, that's to the fourth. No big deal. Which of the following is a remainder? Okay, we're going to do our synthetic substitution, our little box. Remember, take the opposite of this. 1, 6. Do I have any gaps? 3, 2, 1, 0. No, I do not. So drop down the 1. And remember, it's just a whole bunch of multiply, add down. Multiply, add down. Multiply, add down. And it just says which is the remainder, which is my last number. I don't have to put the x's back in. Just find that last number. And then we get another one here with 33. Again, switch my sign. And if some of you are thinking I'm going too fast, it's because you haven't done any of this ahead. It's not for me to have you write everything down. It's for have you to be able to check stuff. Now here I got to be careful. 3 to 1, that's not right. 3, 2, 1. That's what I'm looking for. So if I have a gap in there, if I start counting down from the greatest degree, and there's a missing one, I got to put that in there. Drop my first term down. Multiply, add down. Multiply. Be careful with your signs. Negative times negative is positive. Add down. Multiply, add down. Okay. Find the quotient means the variable terms are going back in. So, if I start at 3, where am I going to start when I come down here? Right, I start one below it. So x squared, x, constant, and if I have a remainder, that gets divided by my divisor on the end. All right. What is the degree of a polynomial? The largest exponent. Degree 3. Even if they're in a different order, just find the one with the largest degree, the largest exponent. Write the equation for a circle with center 4, 5 has radius length of 3. Remember when we're dealing with circles. Opposite, opposite. Opposite of negative 4 is 4. Opposite of 5 is negative 5. And 3 squared is 9. And we're set. All right. Rolling. Almost to the end, people. Just think, you're going to get to do these and have answers in front of you on top. That's going to be so nice. All right, what is the end behavior of the polynomial? Well, one way to find out. Negative 3x to the 6th. Right arrow to get it off there. Same thing with my, whoops. Okay. Let's just look at it. Oh dear, you're like, Harty, like that. Okay, we'll come back to that in just a second. Let's get this part written. Because we can actually do what we need to just with that little piece. So we know x is going to be 1 to negative infinity and 1 to positive infinity. Now, I can see from that little tiny bitty piece down there at the bottom that it's going down on both, but if you're not comfortable with that, okay, here's what I want you to do. We're going to change our window, our y-min, and we're going to do this for a minute, and then we're going to put it back because we're nice to other people. This is what my normal window should look like. Min's at negative 10, max is at positive 10. We're going to change that min to negative 20 for a minute and graph it so it's a little easier for us to be able to see. Okay, now we can see for sure. So what's happening as x goes to the left? Well, I'm going down. Down is negative infinity. What happens is I'm going to the right? I'm going down towards negative infinity. Now that I've gotten my use out of this, I'm going to be nice again. I'm going back to the window. Put it back the way it belongs, okay? Right. Identify the relative min. All right, let's see here. Got to get back to y equals. Got to type this in. And again, I'm not doing this trying to go 100 miles per hour to be mean or on purpose, but I want you to pace this at a decent part to know. Okay, I got to know this well enough to be able to kind of pace this off. So, okay, let's look at the picture here. Okay, so find the y value at the minimum. You're like, Harty, I can't see it. Okay, if I can't see it, because I know it's down here somewhere, that's why we looked at the window a minute ago. Let's say we take our window, and I don't know, let's go to negative 30 and see what happens. Just do a larger number to see if it makes it a little bit easier to see for you. You're like, Harty, holy crap, how low is it going to go? Well, let's look at the chart here for a minute. That looks like that sucker's going kind of low. So it looks like here, like negative 67 is about as low as it goes. I want to find that low point, okay? So let's go to the window one more time. Let's do negative, now let's make sure. Negative 100. Harty. Oh, there we go. That's what I'm talking about. Okay? So I can mess with that a little bit. So now again, to min, second trace. There's my min. So I want to get my cursor guy as close to the bottom here as I can. Once I get him there, 1, 2, 3 to the left, enter. 1, 2, 3, 5, 6, enter. And I'm trapping that minimum in. Boom. Y value we're being asked for. So negative 67.6. That's my relative minimum. But again, it's not terrible to mess with a value on your window if you have to. And then, but again, once we mess with it, we always put it back. All right. Maya, she's shooting an arrow. Negative 16x squared plus 150x plus 3. Yeah, because the negative kind of got lost over here. So, let's take a look at the picture. So now this one looks a little more interesting. Like, this is going to come down in a hurry. Mr. H, making sure he typed it in right. Did he type it in right? No. You're like, really, dude? I'm like, no, this is legit stuff that people do. Okay? I make mistakes too. Now you're like, well, how did you know that? Because it just seemed like that 0 was going to be like no time at all. So let's try this one more time here. Okay, that makes more sense. The arrow's going to hit the ground out here. So, find the 0. Second trace, 2. Okay, now it's going to take a minute. Keep holding to the right and watch your y value. It's going to keep going up for a while, but soon it's going to start coming back down. See, here it comes, below 300, 200, 100. Whoa, there it is. Okay, as close as we can. You know the drill from here. 1, 2, 3 to the left, enter. 1, 2, 3, 4, 5, 6 to the right, enter. And about 9.39 seconds because it's the x value. Okay, even though with these, that's going to be 0 anyway, so that wouldn't make much sense. But again, kind of playing with my button presses is going to be something I need to do. 39. Then he punts a football. Okay, what's the maximum height? Testing it all out here. Now here we have some options though. With Denny's issue, we got options. Now, again, maximum. I want to know what's going on at the top. I can't see the top, Harty. Well, guess what? We need to change this then. So let's try something. Let's try 100. Whoops. Harty hit the wrong thing, didn't he? I'm letting you guys see all the goofy things that can happen on this stuff. I'm telling you. How valuable is that? No, I want the y value is the up and down, Harty. For the love. All right, let's see if that helps us enough or if we need to go to the chart. Nope. You can see it. So there it is. Second trace. Maximum. To the top we go. 1, 2, 3 to the left. Enter. 1, 2, 3, 4, 5, 6 to the right. Enter. Trapped in my max. Okay. Height is the y value. So 74.25 feet would be the maximum height. Now you're like, okay, what if I don't like doing all this window stuff? Is there a way I could get it another way? There is, and here's your other option. Okay. You could do, 1 second here. You could find the x value of your vertex, which is what a maximum is, your negative b over 2a. Negative 68 over 2 times negative 16, which I actually just did right here. But then you're like, well, that doesn't equal this. No, but if I take that value and plug it back in where the t's are, you do see on the calculator that I get the same value and we get the same answer. So I can use the calculator. I can use the x equals and then plug it in with substitution. It depends on what you're more comfortable with. But that's one thing we've tried to teach all along in here is there's multiple ways to get to the answer. And that's what's key here. Okay. Last one. And then again, if we need to go back and talk about some of these, we can do that, or make up an extra problem or two, we can do that too. What are the domain and range of the function? Okay. Domain, x values left to right. Arrows are the key. Arrow left, arrow right. If there weren't arrows, we'd have to be a little more cautious. Now, range isn't quite the same, because these are both going downward. So negative infinity, yes. Where does it look like about the top is, because again, range is y from bottom to top. It looks like it's about at 4, but not quite. I mean, even if you wrote 4, you're going to see an answer that's similar enough that you're going to be able to tell. Okay? So, okay, ladies and gentlemen, this concludes our final review for multiple choice. If there are some places you're still having issues, watching this again is a good idea. Looking at the topic that you have that maybe you're struggling with and looking it up on my website or YouTube page to go back and get some more practice at it, or look at some homework or in old quizzes. Old unit tests can be good ways too of looking at this, or the reviews on those. And if all else fails and you're still looking at something, you've tried some things out, come and talk to me. Let's see how this goes back through, and let's do a great job on this final.